Hi everyone, in this lesson you're going to be learning how to use logarithmic functions. So this is a really important lesson, and I just want to say up front that a logarithm is a new operation and it's going to take a little bit of getting used to. So don't worry if at first this seems, really difficult. The more you use logarithms, the easier it's going to get and the more it's going to make sense. But just remember at first this can be a little bit of a difficult topic. All right, so a logarithm is a quantity representing the power to which a fixed number, the base, must be raised to produce a given number. Logarithms are a convenient way to express large numbers. They're also helpful when we have a variable as an exponent. So here we have the definition of a logarithm. If we have an exponential function, we can rewrite it in logarithmic form. All right, so I have an example here. This is the exponential form of the function, and this is the logarithmic form of the function. So what you want to remember is that we're going to put our base here. This is the base. All right, so this is the base of the exponent. That's what's going to go here. Then we have the exponent. The exponent is going to go to the right of the equal sign because logarithms are exponents. And then we have the answer, which is this guy right here. That's the answer. So we have a base, we have a base, we have an answer, and an exponent. Base, answer, exponent. Let's write that. I like to say bacon and eggs. Base, answer, exponent. Bacon and eggs. That's a way to remember it. And it's read log base A of y, or in this case, log base B of A equals E. Log base B of A equals E. All right, so the best way to get good at these is to just go ahead and start practicing them. I just want to make a note here. Since A is a positive number, A raised to any power x must be greater than 0. Therefore, the logarithm of a negative number or 0 is undefined. Now, when we start graphing logarithms, this is going to make more sense, but the domain of a logarithm is going to be greater than 0. All right, so write each equation in logarithmic form. So we're going to have the log, we're going to have the base, we're going to have the answer equals the exponent. So for the first one, number 1, we've got the log. The base of the exponent is 5. The answer is 25. And the exponent is 2. So log base of 25 equals 2. For number 2, the base is 10. The answer is 1. And the exponent is 0. For number 3, we're going to convert from logarithmic form to exponential form. So what I like to do with these is use an arrow. 2 to the third equals 8. 2 to the third equals 8. 10 to the second equals 100. 10 to the second equals 100. All right, so those are the basics of converting from logarithmic to exponential and vice versa. Evaluate each log using your calculator. We're going to go to Math, letter A. Press the Math button, and you're going to scroll down till you get to letter A. Now, some of you may not have this on your calculator. If you have an older version, don't worry. In a second, we'll go over that. So we're going to pick letter A, and we're going to do the first one, which is log base 10 of 100. And we get 2. Do the next one on your own, log base 4 of 64. Go to Math. Base 4 of 64. We get 3. Now, if that doesn't, if that's not a function on your calculator, you can also use change of base. We've got log base a of x. We could put log of any base in the numerator of x, and then log of the same base in the numerator of a. So, for example, for letter B on number 5, to use change of base, we would have said log of 64 over log of 4. Let's try that. In this case, I'm just using the log button that's right next to the number 7. This is log. This represents log base 10. We'll go over that in a second. And you can do it that way as well if you don't have that log function on your calculator. So for number 6, it says, write a logarithmic expression in terms of base 3 equivalent to the following log base 5 expression. So for this guy, we could rewrite it as log base 10 of 10 over log base 10 of 5. So when I don't write the base, I'm assuming that the base is 10. But they're asking us to write it with the base of 3. So log base 3 of 10 over log base 3 of 5. So these all mean the same thing. And I'll show you what I mean. I'll do them all in the calculator. Go to math. We'll go down to the log function. And we'll put in log base 5 of 10. Or we could write it as log 10. Make sure you use a parenthesis divided by log of 5. So if we go back to math, and we want to use log base 3 this time, and you see that they mean all the same thing. Now, I just want you to see that this is, another property of logarithms. So for number 7, write the log in terms of base 4 equivalent to the base 2 expression. So we know that this is equal to log of 3 over log of 2. And now we're just going to write that in terms of base 4. All right, so the answer is this guy, just like the answer was this guy. So a common logarithm is a logarithm that uses base 10. If no base is indicated, the logarithm is assumed to be base 10. So I showed you that a little bit in one of the previous problems. It's used so often that it's just almost like a shorthand that if there's no base written right there, if there's no base there, we assume it's 10. Again, that's because common logarithms are used so often, there just became this shorthand. We just assume that there's a 10 there. And we can use the calculator button to do that. We're going to go ahead and enter log 3. Just use the log button. That means that log button is log base 10. And we get rounded to the nearest hundredth, 0.48. And now we'll do log 10. And that gives us 1. Now, what we did there was log base 10 of 10. That equals 1. And what you're going to find when you do a lot of these is if we had log base 5 of 5, that would be 1. Log base 20 of 20, that would be 1. Log base 352 of 352, that would equal 1. So like I said, as you get to do these more and more, you're going to start to see, the patterns, and you're going to understand the properties a little bit better. The next thing we have here is natural logarithms. Now, another base that's used often in logarithms is base e. So there's shorthand for log base e of x, and that's ln of x. And this is a really difficult thing for kids to get. We just introduced logs, and then all of a sudden we have this ln feature. It just means log base 8. It's called a natural logarithm. This logarithmic property was developed in another language where the adjective came after the noun, so it's logarithmic natural. We would have probably preferred it to say NL instead of LN, and that's why I think it's confusing. But whenever you see LN and it's confusing you, just rewrite it as log base E, all right? Now, because again, log base E, the natural log, is used so often, there's a special button for it on our calculator. And you can see it's right next to the number 4. So we're going to press that button. It's highlighted in red on my calculator. And just tell it we want log base E of 3. That rounds to approximately 1.10. And then ln of E, that's log base E of E. If you were listening to me a minute ago, you already know the answer to that. Let's put that in our calculator. ln of E, so second. Now the E button is, you have to do second division symbol to get the E button. Okay, log base E of E is 1. All right, moving on, we've got more properties of logarithms. This is all the basics of logarithms. So all of these properties have proofs, and we are not going to do those proofs. You're welcome. You just have to believe me. I think the easiest way to understand the properties is lots of practice. But you could think of, if you have multiplication here, you're going to have addition. If you have division, you're going to have subtraction. All right, there's this wonderful property that allows us to take an exponent and leapfrog it to the front. That's called the power rule, or I like to call it the leapfrog rule. We have the change of base, which we already talked about. All right, and the equality rule just means that if I have a log of the same base in front of both sides on either side of my equation, just like I could add it, I could take it away. So since these are both log base A, I could just take it away and I'm just left with X and Y. All right, so number 10 says condense each log. That means write each as a single logarithm. Whenever you see the word condense, you know that you're only going to be writing the word log one time. For this one, we have log base 3, and because it's subtraction, it's going to mean when we condense them, we're going to have division. And that just becomes log base 3 of 5. This time, we have two properties here. We have the leapfrog, where that 3 can come up, and we have addition. That's going to mean multiplication. All right, so when we're condensing the log and we have addition, it's going to mean multiplication. So we're going to have log base 2 of x cubed. I'll bring that up first, right? And then because we have this plus between, when we condense the log, we're going to have multiplication between. And there's really nothing else we can do with that, so that's our final answer. We have the power rule, we have leapfrog, and then we have plus, which means we're going to have multiplication, and minus, which means we're going to have division. So let's do this sort of in pieces. So we have log base, well, these are all log base 10. Log base 10 of 2 cubed, that 3 is going to come up. And that plus means we're going to have multiplication. So we're going to put a 4 there, and then let's just write that. All right, now 2 cubed is 8, and 8 times 4 is 32. And this subtraction means we're going to have division when we condense the log. So we have log of 32 divided by 16, and that gives us log of 2. All right, we have leapfrog here. We're going to power rule this guy up. The subtraction means we're going to have division between these two. And then this plus sign means we're going to have multiplication. So let's do this one in pieces. We have log base 3 of x to the 4th, and that's going to be divided by y plus log base 3. Let's power rule the 3 up here. All right, now we have this addition between, so when we condense them, it's going to be multiplication. and that's times z cubed. Remember, z cubed is over 1. We want to make sure we don't put that in the denominator. And so that is our final answer. Now, these types of exercises are really good at embedding these properties into your brain. And like I said at the beginning of the lesson, this is not an easy thing at first, but it will get easier with practice. So this time, instead of condensing, instead of writing it as a single log, we want to expand. So we're going to have the word log at least 2 times in our expansion. Now, we have x divided by y. When we expand a log, if we have division, we're going to go and we are going to know that if we have division, we're going to have subtraction when we expand. So we're going to have log base 5 of x minus log base 5 of y. We have multiplication between 3 and x to the 4th. So when we have the multiplication, we know we're going to have addition when I expand the log. We also have a 4 there, which means we're going to use the power rule. So let's do that in pieces. We've got log of 3 plus log of x to the 4th. But we have our power rule, which means that we need to take this 4 and bring it out front. So we're not quite done. So we have log of 3 plus 4 log of x. And when you're expanding, you want to think of it as trying to write the longest possible log sentence you can. You want to use all your properties to make this as long as you possibly can. In letter C, we have multiplication between, which means we're going to have addition, and we also are going to be using the power rule, leapfrog. So we've got log base 7 of a cubed plus log base 7 of b to the 4th, and then we have to use our power rule to bring the 4 in front and the 3 in front. All right, last one, letter D. We have a 3 as an exponent, so I want to leapfrog that out front first. And then I'm going to use subtraction between because we have division. And I'll leave that 3 out here now. And I'm still not done. I've got to bring the 2 out front. Now you could leave it like this, or we could distribute the 3 as our final step. I think I'll do that. So 3 times 2 is 6. And so our final answer is 6 log base 5 of x minus 3 log base 5 of y. And then the last page, we're talking about inverse properties of logs and exponents. Now, we've looked at exponential functions and the graphs of exponential functions. We are eventually going to be looking at the graphs of logarithmic functions. But what you need to recognize is that the function of a log is the inverse of an exponential function. So here's our exponential function, and here's our logarithmic function. Those are the parent functions. And anything that's an inverse will always reflect over the line y equals x. And there are some special properties when we're talking about the inverse properties of logs and exponents. And these are the properties. Now, again, there's proofs to go with this, but we are not going to do the proofs in this class. You just have to know the properties. Now, if I were you, I'd be looking at those properties thinking, I'm never going to remember those. I mean, it takes time to recognize that, you can use some of these properties. Just so you know, if you're taking an IB course, these properties are in the IB formula booklet that you're allowed to use on the IB exam. So these properties are in there. This isn't really something you'll need to memorize, but I think it's something that you want to be able to recognize when you look at it, and it'll just save you a lot of time. So if we use the properties, if we look at number 12, Log base 6 of 6 equals 8. Now, like I said previously, log base 10 of 10 is 1. Log base 15 of 15 is 1. Log base 6 of 6 is 1, so this part here is 1. And I can leapfrog that 8 out front, so I'm using this property right here. So this one is just equal to 8. The beauty of knowing these properties is there is no work. You look at it and you know the solution. Now, number 13 is like this second property. We have b raised to log base b. Here we have 3 raised to log base 3. So our answer is just going to be 2. And we have log base 2 of 2 raised to the negative 1 power. Log base 2 of 2 is 1. That negative 1 can leapfrog to the front. So this is equal to negative 1. So take your time, do the practice. Good luck. Thanks for watching.